All right, ladies and gentlemen, thank you for flying air math on this beautiful day. Today what we're going to work on is spending some time writing what's called linear equations that model real world, also called linear models. So our activity is there a relationship between the length of one's index finger and the length of one's foot. So first what you're going to do is you're going to measure the length of your right index finger, and that's the pointy finger in case you forgot. And the way that we're going to measure that is, so here's your thumb, and here's your index finger, because I'm an awesome drawer. There's your middle finger. So there's going to be a sort of a fold right there and a fold there from where your knuckles are. So you're going to measure pretty much from that fold right there, and just see how long that is. Do not include the nail, just include the flesh part, and don't push it down. So my guess is you're going to get 6 centimeters or 7 centimeters, somewhere around there, maybe even in the 5s. All right. Next, you're also going to carefully measure the length of your right foot, so take the shoe off. And you do have to measure that from the back behind the heel. So on your foot does this, it drops down, kind of wraps like that. So don't measure from here because it's tempting to, if you're just looking at the bottom of your foot. So you're probably going to need to put your foot up against a wall so that you can measure accurately to the end of your big toe. Let's just go with the big toe. All right. So I do have some data here that I'm going to work with. Now notice here that because of my the nature of my centimeters here, the lowest I get to looks like 6.5, and the highest I get to all the way up to 8.3, and then this one goes from 22 to 30. So I'm going to count differently here. So down here is going to be a small little break, and I'm going to start at maybe 6.5 and then count by 0.2s. Remember that when we're doing and filling things in here, if I put a 6.7 and a 6.9, it just fills it up way too quickly. So maybe we'll just skip one every other one. All right, so this one's a 6.7, so that's a 6.9, 7.1, 7.3, 5, and 7.7, and then 8.1, and then 8.3, so 8.5 there. All right. This other one we're going to make a break here too and start counting at 22, 23, 24, 25, 26, 27, 28, and 30, and 32. And clearly we don't need to go all the way to 32, but we always just put a little buffer there. All right, now we start just graphing some of the points. For 7.5, I get 29. So 7.5 gives me a 29 to there. Start plotting a few more, and I get this. All right, so when I plot all of this data, we see this going on. All right, so here's the next step that you're going to do. Step number 3 is that we're going to use a ruler, and we're going to draw a line that goes through the data. Now, here's the key. The data, it does not have to go, it doesn't have to touch any of these points. What we have to do is make a line that we think describes it well. So for example, I wouldn't draw this. This would not be an accurate line right here, right? Because look, I've got some of the data below it and most of the data above it. So I'm not going to draw that. And I'm clearly not going to draw this because that goes exactly through 2 of the points, but it doesn't describe it well. So maybe something that kind of does this. So where some are below and some are above, like this, okay? Now, this is not a perfect 100% line. You're going to try to make yours as straight as possible, and yours might look slightly different than mine. Slightly different than mine. Okay. Now, since I happen to go through a nice point here, the 6.5 and the 22, I have to find another good point-ish. So I'm going to change the color. I'm going to use a yellow dot just to find an estimate. This one looks like it goes through right here. It looks like it goes nicely right there, which that's not part of my data. That just is part of the line. So this one here is 8.3 and a 31, okay? And this point down here, which is part of my data, is a 6.5 and a 22. Yep. And now what I'm going to do with those points is I am going to do exactly what we did before, where we're going to write an equation in slope-intercept form of this line. So I'm going to use point-slope form after I find the point, find a slope. So let me write down here my 2 points so it's a little bit easier to work with. So 6.5 centimeters to 22 centimeters, and the other one is 8.3 to 31. Okay, so first I need to find a slope. All right, so first we're going to subtract our y's. So 31 minus 22 over 8.3 minus 6.5 equals. So I got, coincidentally, exactly 5. Okay, so now we have a slope. By the way, slope means rate of change. So the question is, what's changing? And we'll unpack that in just a second. Okay, next up, we have to choose a point. Doesn't matter which point we choose. I'm going to use the smaller point there. All right, so again, y minus y1 equals m times parentheses x minus x1. So y minus 22 is equal to 5 times x minus 6.5. Now continue, y minus 22, 5x minus, and then y equals 5x minus 10.5. Now, how do we interpret this? What does this mean? What does this mean? Okay, it's a little bit hard to interpret every part of this equation, but here's the key thing right here. 5 means rate of change. And practically speaking, what that means is every 1 centimeter, so this is like an exchange rate, every 1 centimeter on the finger is, well, every 1 centimeter larger on a finger, every 1 centimeter larger on a finger is 5 centimeters more on your foot. So on page 2, we want to talk about 3 different types of something called a correlation. A correlation. A correlation is like a relationship between 2 things. So let's walk through this. A positive correlation looks like this. See how the scatter plot is kind of going up? It's like the bees flying in an upward direction. And here we have a bunch of data, and the bees are flying in a downward direction. And here, they've just been scattered all over. So there's no relationship. In other words, there's no relationship between the x and the y. Here, as the x goes up, as x gets bigger, so does y. Y gets bigger too. So for example, something might sound like this. The more you study, the better your grade. Okay? That would be a positive correlation. The more you study is the better your grade. Well, what would be an example of the more you do something, the less something happens? Good, so a negative correlation here would be time studying might drop down relative to time playing games or something, playing video games, right? Because as you study more, clearly you don't have enough time to do video games, so that's got to decrease. And no correlation would just be stuff happening all over the place. So based on what our previous graph was, most likely we have a positive correlation. In other words, it can be described as this. As the index finger increases in size or length, so does the foot. So to enter stuff into your calculator, you can watch this video. Follow these steps, and then you'll get the answers down here. Our y1, what we're going to do is make sure to round to the hundredths unless it says otherwise. And our y1 is, so when I look at my y1, I get this minus 3.18. So I calculated, I did find what my line of best fit is, and that's it here according to my data. My R equals 0.81, and we'll consider that on the next page. But let's interpret real quick what this stuff means. Remember that this is almost 4 right here. And as we talked about yesterday, this means the rate of change. And it means every 1 centimeter longer on the finger is about 4 centimeters longer on foot. So that's what that 4 means. It's an almost 4. The last thing that we're going to consider before we practice some more is the idea of correlation. Correlation. Okay, the line of best fit will have a special number associated with it. This number is called the correlation coefficient, and we always use the letter R for that. This is how we interpret the letter R, the correlation coefficient. The closer R is to either -1 or 1, the stronger the correlation the data has. So look at these examples down here. So if the correlation is -1, notice all the graph perfectly lines up, and it's a perfect negative slope there. +1 is a perfect positive slope. Look, it's collinear. Everything's in a straight line. Now notice this here. A 0.8 says, well, things are scattered, but generally speaking, they're tightly mixed, right? So you can see that there is a trend here. This one here is far more spread out, but still you see a trend going upward. So that has a very low correlation coefficient, a 0.3. 0.3 still means that it's positive correlation. It's just very weak. So this is a weak positive correlation. This here, these two here, well, actually not the two. This one here is a strong positive correlation. And this one is a perfect correlation. The cost of t-shirts, for example, won't change and it'll line up perfectly. So that would be a very strong one. Our data about the length of our fingers to the length of our foot is this right here. It's a strong correlation. It's not perfect. It's not 100% the same. And so going through this spectrum over here, this spectrum, if we see this being -1, this being 0, and this being on my number line there, this being 1, then the closer we are to -1 and the closer we are to 1, that's the stronger it is. The closer it is to 0, the weaker it gets. And if it is pretty close to 0, like 0.1, 0.2, or -0.1, 0.2, then in that case, you say pretty much there's no real correlation. So the no correlation is somewhere in here. This is about the no. Then we have weak correlation somewhere in there, and this is weak here as well. And lastly, we get strong, and strong correlation is close to or exactly 1. So in this spectrum, we see how things move. Positive is this way, no correlation, very weak. Then we get strong and strongest, and then a 1. Down here, we have a negative correlation, no correlation, but weak. And then here, we get into the strong negative correlation. So let's walk through this example. I'm going to use the TI calculator in order to walk through it. Again, what are our steps? We're going to clear out our data from before, and we're going to enter this stuff into L1, L2. We're going to do our graph, our scatter plot on the calculator. So it's going to scatter here. We're going to draw the trend line, And we're going to figure out what the trend line is, right? The equation of the trend line. And we also want to know what R is, and we're going to make a comment on the correlation. When I did my calculation,